The second reason for avoiding multiple enumeration is that with IEnumerable sequences, you can't always guarantee that you'll get the same results when you iterate through it a second time. Let's have a look at some simple code that will help illustrate this problem. Here you can see I've got a getNumbers method, and it returns an IEnumerable sequence of integers. And I'm going to call that method, and then I'm going to use four link extension methods, count, sum, max and min, to calculate some values from these numbers. Now, when we run this, how many times will we enumerate through the IEnumerable sequence that was returned by getNumbers? Well, we're going to enumerate through 4 times, once for each of these methods. Now, the previous reason I gave you for avoiding multiple enumerations was a performance reason. So if this getNumbers method is really slow, for example, imagine it goes off to the network and the numbers that it's getting are from some external resource, then this code here would be really bad because we'd be going off and getting those same numbers from the network 4 times. But you can see in this example that getNumbers is actually returning a hard-coded array of numbers, and so it's going to be super quick and we've got no performance issues here at all. But what if the implementation of getNumbers instead looked like this? Now getNumbers is returning a sequence of random numbers, and in fact that sequence is of a random length, and this is a completely valid implementation of this function. It also returns an IEnumerable of int. Now, this means that we've got a bug in our code up here, but when we run, it's not immediately obvious what the problem is. These count, sum, max and min values look quite reasonable. But the problem is they're each being calculated from 4 completely different sequences of numbers. And we can make this issue obvious by changing our code to just call the sum method 4 times. So we're calling getNumbers once, but we're calling sum on the IEnumerable of int that it returns 4 times. And now when we run, we can see that we're getting different values for each call to sum, although these two did happen to be the same just by chance. And that's because each time we enumerate through the IEnumerable of int returned by getNumbers, then this call to random.getNext will execute again, returning different results. So how can we fix this? Well, this is an example of a situation in which it's a good idea to call toList. And by calling toList, we make sure that we evaluate the IEnumerable of int sequence only once and cache the resulting numbers into memory. And now, no matter how many times we call sum, we'll always get the same answer. So what does this mean? Well, it means that if you're ever passed an IEnumerable as a parameter, or maybe it's returned to you from a function, then you should avoid enumerating it twice. If you do need to enumerate through it multiple times, then the safe thing to do is to call toList on it first, which will store the results in memory. And then that in-memory copy can be safely enumerated multiple times because that's not going to change. Now this actually raises an interesting question. Should you return IEnumerable from your methods? Let's quickly think about that before we wrap up this module.